Alright guys, I know this is a little bit earlier than normal. I just have some meetings later today and I have to get this done. So I'm going to go ahead and get this session started. I'll post again this on my Instagram story, and I will also post this to YouTube so you guys can watch it later. Well, welcome back. Hopefully yesterday was a pretty easy transition back from our spring break. We had to go through that survey and just get a preview of what the next class is going to be like. I did look at the survey results, so I am kind of just going to slow down the pacing even more. I know for most of you seniors, you guys are ready to be done. I feel that. And so we are just going to go through, really, if we can get through the next two sections before the end of the year, that's good. Okay, so if you were able to print off the note packet, that would have been great. If not, you might have... Yeah, my video is going to keep pausing. The Wi-Fi is not working too good in the house. You might want to write some of this stuff down. So if we look at this, we're going to be looking at not Riemann sums. I've decided to completely take that away, and we're going to learn the shortcut to find a definite integral. A definite integral is an actual value of an integral. So before we were just writing functions, but now we're going to actually figure out what the value is of a definite integral. And so the definite integral first works on one scenario. As long as the function is continuous on an interval. So as long as there's no holes in the graphs or any jumps or any discontinuous points, we can do this. So it's saying this interval from A to B is going to exist. Now that interval is actually going to tell us the area underneath the curve bounded by the x-axis. We could switch it around for the y-axis if we wanted to, but we're not going to do that. I've decided to take that out of the whole section as well. So if I wanted to find the area underneath this curve, we're going to take the integral. There's a way to do this using Riemann sums, which is the summation notation, which we're totally going to skip. So don't worry about any of those summations. That was just kind of a nice practice. If you ever take calculus in college, you'll have to do that. But right now, we're going to skip that. And we're going to add a little bit of notes here. So if I wanted to figure out the integral from a to b of f of x, what we are going to do is, I'm zooming in here, is we're going to take capital F of b minus capital F of a. So remember, the capital F is the integral function. We're going to plug in b, the top number, and we're going to plug in a, the bottom number, and we'll subtract b minus a. So if I wanted to find the integral from -2 to 1 of 2x, first thing I need to do is I need to integrate 2x. And so remember, taking the integral, we're going to leave that number in front alone. We're going to take the power, which is 1, bump it up 1. So 2 goes to 2 and we'll divide. So really, f of x, capital F of x, is equal to x squared. All right, so what we're going to do now is to take our b number and our a number and plug them into the equation. So we would have f of 1 minus f of -2. We're going to plug those in and get our answer. And so if I plug 1 in, let's see, 1 squared is 1, minus if I plug -2 in, -2 squared is 4. So 1 minus 4, we'd have an area of -3. Which we'll explain tomorrow a little bit what that means. But we can have negative areas with integrals. It just means that the function was like below the line. Okay, so that's as far as we're going to go today. Tomorrow we'll go into more detail, so I'll go through some of the homework problems just to kind of help you guys out. So you guys can get... Hey, it's my dog. Alright, so can I zoom that out a little bit? Okay, so going through the homework problems here. So first problem is evaluate the integral from -2 to 3 of x dx. So first thing we need to do is to find capital F of x, so we got to integrate this. So this is technically x to the first. There's no number in front, so there's no number in front here. We're going to make this x to the squared over 2. So there's our function. What we're going to do now is plug in 3 and also plug in -2. So we'll plug in 3. 3 squared over 2 minus, and then we'll plug in -2. -2 squared over 2. So let's see. 3 squared is 9. 9 over 2 is what? 4.5. Minus. Alrighty. Let's see. 2 squared. -2 squared is 4. 4 divided by 2 is 2. So we're really going to do 4.5 minus 2. 2.5 would be the answer. We'll keep this going so you guys can see. Oh no. I just noticed one of the problems isn't showing up. So I will have to fix that. Let's see. Alright, next problem. Here we go. Questions. Integral from 1 to 4. 4x squared dx. Okay, so if we want to find the integral from 1 to 4 of this expression, we need to find capital F of x, the integral function, by taking this function here, 4x, but we're going to bump it up to 3 and divide by that number. All right, so we're going to go ahead and plug in 4 first. So we got 4 times 4 cubed over 3, and then we'll minus 4 times 1 cubed over 3. All right, so I probably can do that in my head. It's like 256 over 3, but turn on the calculator. So we got 4 times 4 cubed, and then we're going to divide that by 3, and then I'm just going to put the answer here. Math, enter, enter. 256 over 3. Minus, all right, if we plug the other one in, that's easy to do in our head. 1 cubed is 1, times 4 is 4, times 3, or over 3 is 4/3. So we got to do, okay, what's 256 over 3 minus 4 over 3? So I already got 256 over 3 typed in. I'm going to minus 4 over 3, 84 even. Okay. Let's see, the next problem, it looks like there is a mistake. It didn't pop up. Looks like I didn't even... Well, you know what, guys? There's no way I can update it, so the third question just enter 0. Sorry, made a mistake. Can't fix it. The answer is 0. Well, there we go. So we'll go over this in more detail, what this means tomorrow, like how do we apply this to our problems, but hopefully that helps you out. Best of luck. Stay safe. We'll see you tomorrow.